Welcome back, 6th grade, to math and some more algebra here that's going to help you later on in the future. Alright, we've added or combined algebraic terms. Today we're multiplying them, and there's a huge difference between the two of them, so please don't get them mixed up. It's the #1 problem people have in algebra, is mixing up combining like terms with multiplying algebra terms. Totally different rules for multiplying. In fact, in many ways, it's much simpler to multiply than it is to combine. All right? So you will recall that when we combined like terms, we had more than one term, right? Two terms. And they had to have the same variable to the same power. And then to combine them, we kept that variable the same and just combined the numerical coefficients. 2 plus 3 of these things, a. 5a, all right? So again, I've got 2 of these things, and 3 more of these things gives me 5 of these things. That's combining. Apples plus apples makes more apples, all right? Now, and again, we're doing more than one term here, all right? This is one key to recognize what's going on, all right? Here, if I have 2a times 3a, that is one term. Remember that a term is indicated multiplication. A term is just a multiplication problem that's separated from other multiplication problems with a plus or minus sign. So 2a times 3a is one term. And all you need to do is simplify that by multiplying it. All right? There's no plus sign here. We don't have to worry about are they the same variable or the same power or anything like that. It doesn't apply to multiplying. All right, we just multiply what we can. We use the commutative property. This is 2a times 3a can be thought of as 2 times a times 3 times a. All right, it's just one long multiplication problem. And using the commutative property, we can switch things around. 2 times 3 times a times a. All right, well, 2 times 3 we can do, that's 6. And a times a is a twice, or a to the second power. In this case, the variable a changes its exponent when multiplied, which is different than adding, all right? Because it's a times a makes a squared. So 2a times 3a is 2 times 3, 6, and a times a squared, all right? Now, you'll see problems like this, all right? Recognize this is one term. This is all one thing. It's just one long multiplication problem. There's no plus or minus sign separating any of this stuff, all right? So, we want to look at this as minus 3 times x times y, right? That's what this is. I'm just blowing it up here. And now that's times, right here, 2 times x times minus 4 times x times y. You see that? This is just one long multiplication problem. And these minus signs are not subtraction, it's multiplication. All right? Everything's getting multiplied, which means that's just one long term. And now we're going to rearrange things, either on paper or in our heads. Later on, you'll be able to do this in your head. But for now, we're going to put all the numbers together. Minus 3, 2, minus 4. All right? I took the numbers, and I'm going to multiply them together to give me one numerical product. I've got 2 minus signs, which means the result's going to be positive, because minus times minus, like sign rule, says the result's positive. So I got 3 times 2 times 4, which is 6 times 4, which is 24. So the result of all the numbers multiply together to make 24. All right? Now if I look at the x's, I've got an x times x, that's these two x's. Here's another x, that's this x, and here's another x. And that's all the x's. How many of them are there? There's 4 of them. So that's x to the 4th power. X repeatedly multiplied 4 times. You see that? And now I look at the y's, and then I've got times y, that's this one, and times this y, there, and that's 2 y's, so y times y, y squared. And so I put it all together, 24x to the 4th y squared, and that's the answer. And notice that that's one term, except it's just much more simplified than that big long thing we started with. All right? And since this is multiplication, the exponents can change. All right? Apples times apples are apple squared, but apple plus apple is just 2 apples. Big difference. Don't mess it up. All right? Let's try another one. All right? So here I can say this is one long multiplication problem. So I look at the numbers. I got a -2. This is a 1, even though we don't write it there, so we don't need to show that, but there's a 1 there. And then this is a 3, so I got -2 times 3 is -6, and that takes care of the numbers. As far as the a's go, I've got 1 and 2 more. That's a to the 3rd power. A times a squared. The product rule says add the exponents. There is a 1 there for the exponent, even though we don't write it. So it's 1 plus 2, and that's why we get 3. For the b's, I got a b and another b and a b to the 3rd. That's 1, and 1 more, and 3 more makes b to the 5th. And that does it. There's the answer. All right. And again, that's one term, and when you're done, you got one term. And yes, the exponents change because we are multiplying. All right. I mean, we can make it more complicated, but you know, now you can start to look at these things and go, okay, the numbers -6 times -2 times -4. Well, I've got 3 minus signs, which means the result is going to be, you're right, negative. So I've got negative, so I can just write a negative sign here because the whole term is going to be negative. Remember, that's just one whole term. And I'm just trying to squeeze it all down by multiplying. And the fact that this x is different than that x doesn't matter in multiplication. It would if I were adding or subtracting, but I'm not, I'm multiplying. So if I look at the numbers, 6 times 2 times 4, 12 times 4 is 48, and 3 minus signs, so minus, so I got minus 48, that takes care of all the numbers. I look at the x's, I got 1 of them, 2 of them, and 2 more, that's x to the 4th. 2 y's, another y is 3 y's, plus 2 more y's is 5 y's, right? Y to the 5th. And then I've got a z. Boom. It's still times z there, so I've got to include it in the answer, even though I'm not really multiplying the z by anything else. And so that's the answer. All right? I take this one long term and I squeeze it down by multiplication into one term. That hopefully is a little simpler to deal with. All right? Now, we've talked about the product rule for exponents. There is now called a power rule, which says that if I've got x to the something power, and I raise what's inside the parentheses to another power, x to the n power to the m power, the answer is the product, multiplying the exponents and not adding them, n times n. Why does that work? Because if I got x squared to the 3rd power. Well, think about what that means. That means I've got x squared repeated 1, 2, 3 times, right? Everything in the parentheses, which just happens to be an exponential thing, big deal. And it is to the 3rd power. So it's a multiplication to the 3rd power. And now the product rule says 2 plus 2 plus 2, that's x to the 6th. But you might have noticed that you don't have to write it 3 times to get 6, right? Because this times that gives you the final thing. This is x to the 2 times 3 power. X to the 6th. That's the power rule. All right? So if I've got xy to the 4th power, all right, you can think of that as x to the 4th power and y to the 4th power. It's kind of like distributive property. the power 4 here gets distributed to both the exponents. Here is 1, and that is 1. So this is 4 times 1, x to the 4th, and 4 times 1, y to the 4th. All right? So there's two ways to think about this. You can think about it as repeated a certain number of times and then add the exponents that number of times. Or you can think about it as multiplication of each individual thing inside the parentheses. And what that looks like is something like this. I got 3x squared y to the 3rd to the 2nd power. Well, that's everything in here repeated twice. So this is one way to do it. And now I just go 3 times 3, that's 9. X squared times x squared, that's x to the 4th. Y to the 3rd times y to the 3rd is y to the 6th. And that's the answer. Or I could do it another method, is to understand that this is 3 to the 1st squared times x squared squared times y to the 3rd squared. In other words, I'm multiplying all the exponents here times 2. 2 times 1 says I got 3 squared, which is not simplest terms. Don't ever leave it like that. If you can simplify it, just write 9. Now I got x squared twice, 2 times 2, x to the 4th, and now y to the 3rd twice, or 2 times 3, y to the 6th, and guess what? It's the same answer. Two different ways to do it. You can break it apart and multiply it however many times the outside exponent tells you to, or you can take that outside exponent and multiply all the exponents inside that way. That's the power rule. And so you're asked to show this two ways, all right? Here's something inside parentheses to the 2nd power. So how could you show this two ways? Well, one way would simply be to repeat what's inside the parentheses twice. Minus 3a squared b squared b to the 3rd times minus 3a squared b to the 3rd. And so I got minus 3 times minus 3 is 9. A squared times a squared, a to the 4th, and b to the 3rd, b to the 3rd, b to the 6th. Or here, minus 3 twice, 9, a to the 4th, b to the 6th. Those are the two different ways to do it. And notice that this minus sign is inside the parentheses. So it gets repeated, the minus sign gets repeated twice, which makes it an even number of minus signs, which means the result has to be positive. All right. All right. So give this a try. Lesson 87, A to L. Now, A to L, everything is one term, and you're simply simplifying it by multiplying. But I threw in number 30 here because that's a combine like terms, all right? Please, the biggest mistake people make is they start mixing up multiplying with combining. Please don't change the exponents on number 30 when you combine like terms, and everything will be just fine. All right? We'll see you later.